This is chapter 9.2, or really it's in the book section 9.2, exercises 1 through 12. And these are exercises relating to the binomial theorem, doing a binomial expansion using binomial theorem. And in our quick review before this, we essentially expanded out binomials by hand, and now we have a chance to use formulas and the calculator to help us do these things. In this case, in problems 1 through 4, we're asked to expand a binomial using a calculator to find binomial coefficients. Well, to do that in a calculator, I want to go ahead and write the notation first. There's a notation called NCR, which stands for N choose R. So I'll write N choose R. In this case, we're going to do a full binomial expansion, we're going to choose all the values of R. And to do that, we have quantity A plus B to the fourth power. And so R, well, N is going to be equal to the power of the expansion, which is 4. And R is going to be, I'm going to put in set notation, 0, 1, 2, 3, and 4. So we're going to find all these R values, and that's going to help us write out a complete binomial expansion of quantity A plus 4 to the fourth power. So we'll go to the calculator, and we're going to go get a, let me move this over here a little bit, make sure everything's on screen. We go get a calculator page. I go down here and press enter. We have a calculator page, and we go to menu, and this resides, this binomial expansion, within the probability. So we can scroll down to 5, or we could just press 5. And then we're going to try combinations, which is 3. I'm going to scroll down to 3, press enter. We could have just pressed 3. Here we have NCR. And the first thing we're going to put in is N. And just going back to our problem here for N, we had N equals 4. And so in our calculator, we put 4, comma, there's our comma, and then we're going to put open brackets by putting control and open parentheses. And we're going to put in the values for R, which is going to be 0, 1, 2, 3, 4. Now, total instances of R, they're going to be one more than the value of N. When you do a complete binomial expansion, we press enter, and we get 1, 4, 6, 4, 1. So that's the binomial pattern we're going to use. So we go back to our exercise. We'll say 1, 4, 6, 4, 1. This has to be, it's going to be symmetrical when you have an expansion. So what you're going to have is, our expansion is going to be 1. I'll put 1 out front here. A to the fourth power, and B to the 0 power, plus, then we use the 4, A to the third power, B to the first power, plus 6, A squared, B squared, plus 4, A to the first power, B to the third power, and then finally plus 1, A to the 0 power, B to the fourth power. And then simplifying all these, 1 will just, we don't even have to write that down. We have A to the fourth power, and B to the 0 power is 1, so we don't even have to write that down. Plus, we have 4 A cubed, A to the third power, and B, the first power, is just going to be B, plus 6. You have a to the second power, b to the second power. Make sure that's legible. And then we have plus 4, a to the first power, we'll just leave that as a, b cubed. And then plus 1 times a to the 0, that's 1 is 1, a to the 0 is also 1, so we're going to be left here with b to the fourth power. So this is our complete binomial expansion, having used a calculator. We could have done this without a calculator, but it would have been more involved. So that's our first odd number problem in this set. We're going to go on and look at problem number 3, the next odd number problem. Here we have quantity x plus y to the 7th power. So it's going to be a similar type of arrangement. In fact, what I'm going to do in this instance is you just kind of write this out first and then slip in the coefficients later. Okay, so we're going to have, our first term is going to be x to the 7th power, y to the 0 power, and it'll be some coefficient times that, plus, we're going to put some coefficient x to the 6th, y to the 1st, plus some coefficient times x to the 5th, y squared, plus some coefficient times x to the 4th, y cubed, plus some coefficient times x to the 3rd, y to the 4th, plus some coefficient times x squared, y to the 5th, plus some coefficient times x to the 1st, y to the 6th, plus some coefficient x to the 0, y to the 7th. We just need to fill in the coefficients and then simplify. So to do that, we go back to our calculator and we go to an NCR by going Menu, 5, I'm just going to press the numbers, probability, and 3 combinations. And we're going to put in, we know we have 7 for n, comma. We get our brackets by pressing Control, then the bracket key, and we go and put in 0, comma 1, comma 2, comma 3. Now, if we didn't want to put in, we had all of our coefficients, we wouldn't have to enter all these. We could just enter the third term, we get the coefficient for the third term. But since we're trying to do a complete expansion, we're going to want to get all these coefficients. And we're going to have 8 total from 0 to 7. And here's what they are: 1, 7, 21, 35. 35. 1, 7, 21, 35, 35. Is that going to be 8 of them? Yeah, it should have 8. 1, 7, 21, 35. I'm just doing it from memory. 1, 7, what was that next one? 21, 35. Okay. 21, 35, and we have 35 here, and 21, and 7, and 1. And simplifying out, we have x to the 7th plus 7 x to the 6th y, y to the first power is just y, plus 21 x to the 5th y squared, plus 35 x to the fourth y cubed. Is that pretty legible? That y x to the fourth y cubed plus 35 x to the third, or x cubed, y to the fourth, plus 21 x squared, y to the fifth, plus 7 x to the first power, which is going to be 7x, y to the sixth, plus 1 x to the 0, all that's just going to be 1. So we're just going to be left over with y to the seventh power at the end here. And so this is going to be our complete binomial expansion. Again, we could have done this longhand. Would have taken 15-20 minutes or more with vast opportunities for mistakes. Let's go on to our next set, and this is a different instruction. Expand the binomial using Pascal's triangle to find the coefficients. Well, Pascal's triangle is simply like this. I'm going to write it in terms of A and B, and we're going to refer back to it. That's going to be, if we have A, only A plus B to the 0 power, we get 1. If we have A plus B to the A plus B to the first power, it's going to equal 1A. I'm going to put 1A plus 1B. I'm just writing these out here without the plus sign. If we have quantity A plus B squared, we're going to get 1 goes like this. The 1 will continue over here. So we're going to have 1A. We're going to have 1 plus 1 is 2. So we have 2AB plus 1B. And for the third power, quantity A plus B to the third power, and this is going to help us to answer our question. We're going to have additions here, and we're continuing down the edge where we have 1A to the third power, and 1 plus 2 is 3. So we're going to have 3, and that's going to be A squared B. Oh, by the way, this is going to be this is going to be squared here. This is going to be A to the third power here. We're going to have this one coefficient is 3. It's going to be A squared B, 3 AB squared plus 1B to the third power. So that's going to be our expansion. And so to answer this, we're going to, I'm going to go over to the left and write in, okay, to find the coefficients. We're just going to write, it's going to be x instead. So our answer is going to be x cubed plus 3x squared y plus 3xy squared plus y cubed. So this will be our expansion using Pascal's triangle. And the triangle we get by adding things together. And so I'm going to leave this up here like this to continue on, because I think in problem number 7, we're going p plus q to the 8th power. And so it really gets more complicated. But I'm going to go back here to the triangle we started. I'm going to have to bunch up a little bit. But if we have, before I do that, I wonder if I can just move my answer out of here. Let me do this. There we go. I just moved my answer out of the way just to leave more room. Okay. Let's see. Okay, we're going to have quantity A plus B to the 4th is equal to 1A to the 4th. We're going to have 1 plus 3. 1 plus 3 is going to be 4. A cubed B, and then 3 plus 3 is 6. 6, let's see, it's going to be A squared, B squared, right? B squared plus 4 AB cubed, and on the outside we're going to have B cubed. So that's to the 4th, and the 5th, I'm going to write it a little smaller because we're going to need the room. We're going to have 1A to the 5th, and we're going to have 1 plus 4, we're going to have 5. A to the 4th B, we're going to have 4 plus 6, 10. A to the 3rd B squared, we're going to have 6 plus 4, 10. A squared B cubed, and we're going to have 4 plus 1, which is going to be 5. 5 A B to the 4th power plus B to the 5th power. I messed this up here, didn't I? Where this next row up is going to be B to the 4th. Okay, and we have, next we have quantity A plus B to the 6th is going to be equal to, we're going to have 1A to the 6th, and then 1 plus 5 is going to be 6. 6 A to the 5th B, and then 5 plus 10 is going to be 15. A to the 4th B squared. We're going to have 10 plus 10 is 20. A cubed B cubed, and then 10 plus 5 is 15. A squared B to the 4th, and then 5 plus 1, we're going to have 6. A B to the 5th, and then we're going to have simply B to the 6th. And we go on to quantity A plus B to the 7th. You can see using the calculator is a lot easier. We have 1 A to the 7th, 1 plus 7, we have 1 plus 6, excuse me, is going to be 7. A to the 6th B, 6 plus 15 is 21. Remember the earlier problem we did? I think problem 3. These coefficients should be the same. We're going to have A to the 5th B squared, and then 15 plus 20 is going to be 35. A to the 4th B cubed, And then we have 20 plus 15 is also 35. So you have 35 a cubed b to the fourth. And then we have 15 plus 6 is 21 a to the fourth b cubed. Then we're going to have 21 and 7. Something's messed up. 3. Okay, I got it messed up here. I keep track of these things. Okay, it's going down. A squared, it's going to be 21a squared b to the fifth. And then we have 1 plus 6. We have 7 a to the first power b to the sixth. Then we're going to have b to the seventh. Okay, finally, we're going to have here at quantity a plus b to the eighth, and we're going to be able to answer this here. We're going to have 1a to the eighth, and we're going to have 1 plus 7. We're going to have, it's going to be 8a to the seventh b. 7 plus 21 is going to be 28. That's going to be a to the sixth b squared. 21 plus 35 is going to be 56. We got 56 a to the fifth b cubed. And 35 plus 35 is going to be 70 a to the fourth b to the fourth. And we're going to have symmetry, so we're going to go to 56 a to the fifth b cubed. And we're going to have 21 plus 7 is 28. 28 a to the, man, I'm getting them backwards again for some reason. Let me fix these. Calculator's a lot easier. Okay, we have a to the third b to the fifth. Okay, plus 28. Okay, yeah, 28 a squared b to the sixth. We have 7 plus 1. We're going to have 8 a b to the seventh, and then we're going to have b to the eighth power. So our coefficients are 1, 8, 28, 56, 70, 56, 28, 8, and 1. So we go over to A, we go to part 7. So we have 1, 8, let's see, is it 21? No, 28, 56, 70. (28), 56, 70, and then we go to 56, 28, and then 8, and then 1. And so our expansion is going to be 1 p to the seventh, no, p to the eighth. That's right, we're going to the eighth power, right? 1 p to the eighth plus 8 p to the seventh q plus 28, let's see, p to the sixth q squared plus 56 p to the fifth q cubed plus 70. We have p to the fourth q to the fourth plus 56 p to the what is that? Third, q to the fifth, plus 28 p squared q to the sixth, plus 8 p q to the seventh, plus q to the eighth. So that's going to be our binomial expansion. Still long and drawn out, not nearly what it would be by just hand multiplying these things together, but still a bit tedious. All right, on to problem number 9. Evaluate the expression by hand using the formula before checking your answer on a grapher. Okay, we're going to do it 2 ways then. And again, the NCR, and the formula for NCR is going to be, and so it's going to be n, which is 9, choose 2. So what we're looking at is we have n, which is 9, and then choose, we're going to have the second. We put that in the calculator, if we're going to do. For the formula, the binomial theorem is n factorial, which is a, okay, over r factorial times quantity n minus r factorial. And in this case, we have n, which is 9 factorial, over r, which is going to be, what, 2 factorial, times quantity 9 minus 2, which is 7 factorial. And so we're going to go on our calculator. So basically, this is going to be using our calculator 2 different ways to find, we hope, the same thing. Okay, to use the formula, I'm going to get a, let's see, let's get a division thing here, and go to probability, menu, probability, and choice 1 is factorial. So that's not what I want. I want to go ahead and put in 9 first, right? Then go get the factorial, right? Probability. So we have 9 factorial divided by 2 factorial times, we'll put parentheses, 9 minus 2, and we're going to put factorial here, which is going to be 7 actually. We go to probability 1, and we press enter, we get 36. So 36 would be our answer. So let's go ahead and we'll say equals 36. And we can go in our calculator and do this the different way, like we did earlier with these on top. We go to menu, probability, combinations. We're going to put 9, comma. We get our bracket here by pressing Control and the bracket symbol, and we just want 2. So we press enter, we get 36 in brackets, which is a check. So we go up here and we have checked using our grapher. It really wasn't too much easier to do it that second way than it was the first time with the binomial theorem formula, was it? Let's go to problem number 11. N choose R using the formula. So NCR, the binomial theorem we have, I'm going to write down n factorial over r factorial times quantity n minus r factorial. In this case, we're going to have 166 factorial over 166 factorial times n minus r, which is going to be 166 minus 166 factorial. I think we're going to have cancel. I think we're going to equal 1 when we get to everything. Let's put that in our calculator. We will get our division. Oops, what am I doing here? Got the wrong thing. Control. There we go. We're going to put 166 factorial over 166 factorial times, in the denominator, I'm just going to put 0. I know 166 minus 166 is 0, so I'm just going to shorten that to 0 and put a factorial here, probability 1, and we get 1. That is our answer. Okay, so we go over here to our, oops, wrong exercise, equals 1. We can go to our calculator again, use this NCR thing. You'll see that it's going to be not too much less involved here. So n is 166, right? And we go comma, and we go to our brackets. Oops, I got the wrong thing there, didn't I? Okay, control, yeah, okay, that's the right thing there. We'll put in 166, we get 1. Same thing. So we checked using the grapher, and that is our answer. And those will be the exercises we're working on this video lesson. The other problems, we're going to work on problems 13 through 26 on the next one. And I thank you for viewing.